Hi everyone, welcome to assignment 13. We're going to begin reviewing for our assessment. So in the Trig Basics unit, there was a whole lot of new vocabulary, and this whole thing about radians. So let's look at some things. I want the complement, and I want the supplement, and I want a positive coterminal angle, and I want a negative coterminal angle. Okay, and let's start with something gentle like pi over 6. Okay, so what do we know about complements? Complements add up to pi over 2 because this is radians. If I had degrees, then complements would add up to 90 degrees. I hope you remember our little formula that the complement is pi over 2 minus theta. So pi over 2 minus pi over 6, 3 pi over 6 minus 1 pi over 6 is 2 pi over 6. 2 pi over 6. And the supplement, what's the formula there? Sure, the supplement is equal to pi minus theta. Pi over 2 minus theta for complement, but pi minus theta for supplement. So pi minus pi over 6 is going to be 5 pi over 6. Positive coterminal angle, remember to find a positive coterminal angle, we're going to add 2 pi to that. 2 pi is 12 pi over 6, so I get 13 pi over 6. And a negative coterminal angle, I'm going to subtract 2 pi from that. So pi over 6 minus 12 pi over 6, and I have negative 11 pi over 6. Got it? Understand? Feeling good? Okay, how about this one? 45 degrees. You fill out the column. I mean the row. Ready? Okay, so the complement of 45 is 45, and the supplement of 45 is 135, because these should add up to 180. And this should be 90 minus theta. Good. Positive coterminal angle. So I'm not adding 2 pi, I'm adding 360. So 360 gives me 405. And what about a negative coterminal angle? Well, I'm going to subtract 360. 45 minus 360 is going to be negative 315 degrees. Good, good. Okay. Oh, this one. 2 pi over 3. Go. Yeah, it doesn't surprise me that you're a little troubled by that. So if I use pi over 2 minus theta, and my theta is 2 pi over 3, when I make a common denominator, I see that I'm doing 3 pi over 6 minus 4 pi over 6, and that's negative pi over 6. Complements have to both be positive, 2 positive angles that add up to pi over 2. Well, yeah, no. And why? Well, think about it. Here's pi over 2, and I want 2 positive angles that add up to that. But 2 pi over 3 is already bigger than that, so there's no complement. No complement for 2 pi over 3. And what about for supplement? Well, supplement I can still do pi minus theta, pi minus 2 pi over 3. So 3 pi over 3 minus 2 pi over 3 is 1 pi over 3. And a positive coterminal angle, if I add 2 pi to this, I get 8 pi over 3. And if I subtract 2 pi from this, I get negative 4 pi over 3. Good. Okay. I kind of want to do another one or two. So let's erase this part. Yeah, how about, oh, yeah, how about this? How about 7 pi, 3 pi over 5? Yeah, I agree. I don't know that from my unit circle. But that doesn't stop us from finding all these things. Give it a try. Think about it. Okay, how'd it go? Complement. So pi over 2 minus 3 pi over 5. Guess I need a common denominator. 5 pi, 6 pi over 10. Yeah, I get negative pi over 10. I can't have a negative. This one must be bigger than pi over 2. So no complement. Supplement? Sure. Pi minus 3 pi over 5 is going to give me 2 pi over 5. Positive coterminal angle? Sure, I can do that. I just have to add 2 pi. Well, 2 pi is the same as 10 pi over 5. So 3 pi over 5 plus 10 pi over 5 is going to be 13 pi over 5. And a negative coterminal angle, I'm going to take 3 pi over 5 and subtract 2 pi. Subtract 10 pi over 5. And I get negative 7 pi over 5. Okay. How about this one? How about, how about this one? 1. Now, there's no degree symbol, so this is 1 radian. Give it a try. That's right. The complement would just be pi over 2 minus 1. The supplement would be pi minus 1. Positive coterminal angle, 1 plus 2 pi. Negative coterminal angle, 1 minus 2 pi. Easy peasy. Yeah, don't get freaked out because that doesn't have any pi's attached to it. Okay. How about, how about converting? I hope you haven't done a lot of this, but you should know how to do it. I want to convert from radians to degrees or from degrees to radians. So 2 pi over 9. How many degrees is that? Give it a try. Well, yeah, you're supposed to know that. Come on now. The conversion factor, when we want to go from radians to degrees, is 180 over pi, right? Because then the radians can cancel and we're left with degrees. Oh, a little canceling here. And I get 40 degrees. Cool. And if I wanted to go from 40 degrees to radians, I'd multiply by pi over 180. Remember, we always want the units to be the same on the diagonal. And I get 2 pi over 9. Ta-da! Okay, your turn. 7 pi over 15. Please convert that from radians to degrees. 5, 4, 3, 2, 1. Okay, so we have 180 over pi. We're going to cancel. 15 go into 180? Sure does. 15 goes 1 with 3, 0, 30 left over 12. So 10 times 15 would be 150 plus 2 more 15s, 30. Yep, that works. So that's going to go in. I'm going to have a 12. I've got 12 times 7, which is 70, 84 pi. Nope, the pi's cancel. 84 degrees. Whoa, I don't think I was expecting that. We were talking about 7 pi over 15. 7 pi over 15. That's half pi. Okay, sure, I buy that. See, it's good to think about your solutions and their reasonableness. How about taking 205 degrees and tell me how many radians that will be? 5, 4, 3, 2, 1. Okay, so if I multiply by pi over 180, I can figure this out. So I know that this is 41 if I divide this by 5, because there are 25s in 100, and this is 200, so that's 2 times 20 plus 1 more. Times pi over, and how many times does 5 go into this? 20 plus 16, 36, and I get 41 pi over 36. I'm just going to check to make sure that that stuff that I'm doing in my head is 41, good, and 180 divided by 5 is also 36. Fabulous. So we went from degrees to radians. How about this one? Can you do this one? 13 pi over 15. Oh, we did a pi over 15. How about 5 pi over 9? Will you please convert there? 5 pi over 9. Good. Nice. Yeah, I want pi on the bottom and 180 on the top. The pi's will cancel. The 9's will cancel. And I'll end up with 5 times 20, or 100 degrees. Interesting. Okay, and what about 165 degrees? How can I convert that to radians? Convert 165 degrees to radians. Times pi over 180 degrees. We need those units to cancel. 5 goes into both of those. I know that's 36 because we just did that. 5 into here is 3. Yeah. Times pi. Ooh, I could take a 3 out of both of those. 11 over 12 pi. 165 degrees is the same as 11 over 12 pi. Good. Okay. How about some of these? Okay. Sine of 2 pi over 3. 5, 4, 3, 2, 1. You should have root 3 over 2. Because remember, we're talking about this angle here. 2 pi over 3. This is negative 1/2. This is root 3 over 2. Sine is the y value. How about cosine of 7 pi over 6? 5, 4, 3, 2, 1. So 7 pi over 6 is here, and cosine is negative root 3 over 2. Okay. Tangent, 4 pi over 3. 4 pi over 3. 5, 4, 3, 2, 1. So we know that's going to be the same as sine of 4 pi over 3 over cosine of 4 pi over 3. Well, the sine of 4 pi over 3 is negative root 3 over 2, and the cosine of 4 pi over 3 is negative 1/2. So if I do that flip and multiply, I end up with positive root 3. The tangent of 4 pi over 3 is positive root 3. Hey, remember, when you're doing these practice problems, pause the video. Then you'll have as much time as you need, right? Don't try and keep up with this pace here that I'm doing. Pause the video, do the problem. Come back when you're done with the problem. Give yourself that time, okay? Okay, how about secant of 5 pi over 6? Secant of 5 pi over 6. Yeah, so what is cosine 5 pi over 6? The x value at 5 pi over 6 is negative root 3 over 2, and secant is the reciprocal of that. So secant of 5 pi over 6 is going to be negative 2 over root 3, and if you want to rationalize that, we should have negative 2 root 3 over 3. Okay? How about cotangent of 15 pi over 4? Oh, yeah. 15 pi over 4. Not on my unit circle. How am I supposed to do those problems? What is it that I needed to do in situations like that? Do you remember? That's right. We need to use a coterminal angle. So I'm going to subtract 2 pi and get 7 pi over 4. So now I'm asking what's the cotangent of 7 pi over 4? And while that is on the unit circle, I still may not be comfortable. So maybe you want to say, well, cotangent is cosine over sine. We know the cosine of 7 pi over 4 is root 2 over 2. And the sine of 7 pi over 4, well, in the fourth quadrant, sine is negative. So I get negative root 2 over 2. And that's going to give me negative 1. The cotangent of 15 pi over 4 is negative 1. Fabulous. Okay, how about cosecant of 23 pi over 6? Cosecant 23 pi over 6. So, yeah, that's not on my unit circle. You better subtract 2 pi, which is 12 pi over 6 in this case. So I have 11 pi over 6. Oh, I know where 11 pi over 6 is. It's this angle. That's 11 pi over 6. Cosecant, that's the reciprocal of sine. Well, the sine here is negative 1/2. The sine of 11 pi over 6 is negative 1/2, which means that the cosecant of 23 pi over 6 will be negative 2 over 1. Okay? Okay. Oh, negative angles? Sure. How about cosine negative 7 pi over 6? 5, 4, 3, 2, 1. Well, there's negative 7 pi over 6. We want this one. That's cosine of 5 pi over 6. Now, if I can't sort of see it from the picture, no worries, because we know about coterminal angles. Let's add 2 pi. Negative 7 pi over 6 plus 12 pi over 6 gets me up 5 pi over 6. And the cosine at 5 pi over 6 is negative root 3 over 2. All right? And how about this one? How about the sine of negative 8 pi over 3? Find the sine of negative 8 pi over 3. 5, 4, 3, 2, 1. Well, if I add 2 pi to that, that's going to be the same as saying negative 8 pi over 3 plus 6 pi over 3. When I get negative 2 pi over 3, that's still not on my unit circle. So let's take that negative 2 pi over 3 and add another 2 pi to it. And we'll get 4 pi over 3. So this is the same as sine of 4 pi over 3. And we know the y value at 4 pi over 3 is negative root 3 over 2. Okie doke. I mean, really, I do need my unit circle knowledge. Yeah, no way I can figure that out without using the magic calculator unless I know my unit circle values. Okay, so practice those. Definitely let Mr. Paz know if you need more practice with those. But I'd like to find, how about this? Find tangent theta given cosecant theta is negative 17 over 8 and cosine theta is greater than 0. That's right, this is a draw a triangle problem. So draw that triangle, label it properly, and then find the tangent in that picture. Pause the video, give it a try, come back when you're ready to talk about it. Hey everyone, welcome back. So, I know that cosecant, like sine, is negative in quadrants 3 and 4. Cosine is positive here and here. So I guess I'm drawing a fourth quadrant triangle. Remember, not to the y-axis, just to the x-axis. Cosecant is, and this is important, cosecant is hypotenuse over opposite. See how this is down here in negative land? The hypotenuse can't be negative. Hypotenuse is always positive. This is where the negative goes. And it really does need to go there. If you put it here, you're going to end up with the wrong answers. So think about that. Okay? Think while doing. Now, I need to find this. Yeah, because tangent is opposite over adjacent. So I'm going to use Pythagorean theorem. X squared plus negative 8 squared equals 17 squared. 17 squared is 289. I believe that's true. Yep. Equals 64 plus x squared. So if I take that 289 and I subtract 64, I get x squared equals 225. And when I take the square root of both sides, I have x equals, isn't that 15? Square root. Sure is. So actually, oh look, it's a triple. 8, 15, 17. Yeah, it is. So, what did we need to do? We need to find the tangent. Tangent is opposite over adjacent. So I know that tangent theta is negative 8 over 15. Ta-da! Good. How about this one? How about cotangent theta is negative 12 over 5, and we know that sine of theta is sine of theta is greater than 0. Okay, and what would I like you to figure out? I would like you to figure out secant of theta. So figure out which quadrant to draw the triangle in, and then after you've drawn the triangle and labeled the parts appropriately, tell me the secant in that picture. Yeah, I like to think this is pretty straightforward. Sine is positive in quadrants 1 and 2. Cotangent is negative in quadrants 2 and 4. So I need to be drawing a second quadrant triangle. Okay. Cotangent is adjacent over opposite. 5, negative 12. This will be 13, whether we recognize the Pythagorean triple or whether we use the Pythagorean theorem. Then all we need to do is find secant. And secant theta is hypotenuse over adjacent. And so we're going to have 13 over negative 12. Good? All right. Where's that next one? Oh, here it is. Sine of theta is negative 15 over 9. And we know that secant theta is less than 0. And I'd like you to find tangent theta. Okay? Give that one a try. Sure. Sine is negative in 3 and 4. Secant and cosine are negative in 2 and 3. So I'm going to be drawing this triangle in third quadrant. Always to the x-axis, never to the y-axis. So we know that, whoa, why didn't you say something about that? That's not possible. Why is it not possible? Sine can't be smaller than negative 1. The hypotenuse isn't on top for sine. It's on top for cosecant. So that's like that. Okay, so we've got negative 9. We've got 15. In order to find tangent, not only do I need the opposite, but I also need the adjacent. How am I going to find that? Yes, I could use the Pythagorean theorem, or I could recognize my triples. And so this would be 3 times, 3, 4, 3, and 5, and so this one is 4. That's how I got that 12. So my tangent, opposite, is negative 9 over adjacent 12, or negative 3 over 4. Ta-da! Good. Nice. Yeah, I think we could do one more, 2 more. Ooh, I flipped the page over. There's some stuff to do over there. Yeah, let me know if you need more of those. Otherwise, I'm just gonna take a look at what happens when you flip the notes page. Hey, so arc length. Remember the formula? Hope so. That's the arc. There's the radius, and there's the angle. First, even before I rewrite down that formula, theta must be in radians. So if someone gives you degrees over here, then you've got to say what? You've got to say, I better convert those degrees to radians, because you can't use this formula, S equals R theta, with degrees. If you do, going to be wrong every time. Don't even bother. So let's figure this out. If theta equals pi over 4 and R equals 3 inches, what's S? No problem. We know that S equals R theta. And so I end up with 21 pi over 4. And since these were inches, my arc length is going to be inches as well. S equals 21 pi over 4 inches. Radius and arc length share the same units. Okay? How about this one? Theta equals 120 degrees, and R equals 8 miles. Find the arc length. Give it a try. All right. So, did you say S equals R theta? And did you come up with 960 degrees? Well, that would be really wrong, because you're going to have to take that 120 degrees and convert it into radians. And so I get 2 pi over 3 times 8, or 16 pi over 3 miles. Okay, remember, theta has to be in radians. Now, it may be the case that you're given the angle and the radius, but it may also be the case that instead you're given, no, I don't know, how about theta equals pi over 4 and S equals 15. Sorry, brain freeze there for a second. 15 pi over 8. All right. So, S equals R theta. I'll plug in my S, 15 pi over 8. I'll plug in my, oh, I don't know R, but I do know theta. Great. So I want to solve for R. And, you know, a lot of students want to say, hey, let's divide by pi over 4. But doing that gives them a complex fraction over here. And I'd really like to say, let's multiply both sides by the reciprocal. Those all cancel. And here, I don't have that complex fraction. I've already done the flip and multiply. And I get 15 over 2 equals the radius. I didn't have any units here, so I got no units over here. All right. All right. How about, here's our circle, here's our central angle. Let's say that this is 70 degrees and that this is 5 centimeters. And the arc length I want to know about is this arc length. Not this one. Excuse me. Not this one. I'm looking for this one. Okay? So I'm doing S equals R theta. I know my radius is 5, but what's my theta? Oh, it's degrees. Let's change it over to radians. Times pi over 180. So I get 7 pi over 18 is theta. Great. So 7 pi over 18. And so if I multiply, I get that S equals 35 pi over 18. And why does that get marked wrong? Well, I agree. I left off the units, centimeters, because they're the same as the radius. But no, I wouldn't have marked you wrong on that. At least I don't think so. So yeah, what's wrong with this? Well, this is this arc. I want this one. You found for 70 degrees, but I was asking about that one. 360 minus 70, 290 degrees. My angle isn't 70, my angle is 290. Ding, ding. So I end up with 29 pi over 18. That's my theta from here to here. Not this one in here. No, we were told to find this arc. So let's plug in what we know. We've got 5 centimeters times 29 pi over 18. All right, so 145 pi over 18, and those were in centimeters, is our arc length. Fabulous. Okay, last thing I want to do with you is do some converting from decimal degrees to degrees, minutes, and seconds, but also from DMS to decimal degrees. So, do you remember how to do it? Let's start with 13 degrees, 24 minutes, 16 seconds. So when we have a problem given to us in DMS, degrees, minutes, and seconds, we said that we could take care of that on our calculator. So 13, where's the degree symbol? It's under angle. Okay, it's under angle. Second angle, there's the degree symbol. And now we want 24 minutes. That was in that same place. There it is. And now we need 16 seconds. But if I go back to angle again, no, there's no seconds there. Where's seconds? And so here's seconds, right above the plus sign in green. So I want green plus sign. And when I hit enter, I get 13.404 degrees. There's my decimal degrees. Okay? Why don't you try one? I like this one. 22 degrees, 15 minutes, and 31 seconds. Five, 4, 3, 2, 1. Well, I got 22.2586111. 3 decimal places, so this will be 22.259 degrees. Okie doke. Okay, how about we go the other direction? How about I give you decimal degrees? 31.1286111. 1111. And you tell me DMS. Okay? Do you remember how to do that? So you type in that angle, 31.128611234. Good. And then you say math, angle. There it is. And it converts to 31 degrees, 7 minutes, 43 seconds. So what did we have to do? We typed this in. We went over to angle. We chose convert to DMS, hit enter, and hit enter again. Okay? So why don't you do this one? How about 40.2533333? Okay, please convert these decimal degrees to degrees, minutes, and seconds. Well, how did it go? Did you get it? Convert. Did you get 40 degrees, 15 minutes, and 12 seconds? Because I did, and so you should. Okay. All right. Well, that was a bunch of review for us. We'll see you in the next video, our last review before the assessment, and we'll see what else is left for us to talk about. Okay. Take care, everyone.